Hello guys, today we are going to learn about the rotational motion. Okay, so in the rotational motion we are going to specifically cover the applications of the perpendicular and parallel axis theorem. Before that, we are going to know about what do you mean by the parallel axis theorem and perpendicular axis theorem and what are the derivations. Parallel axis theorem given by I naught is equal to IC plus MH square. Before that, we must have to know about what is I naught, what is IC and MH square. What is the meaning of that? Here in the rotational motion, the body is in state of rotation. Okay, the body is in state of rotation, means the body is rotating for an axis of rotation, here let's take about let's take about the parallel axis theorem. First of all, what is I naught? I naught is the moment of inertia where we are gonna to be find out. I naught is that moment of inertia, about that point. Actually, it is the moment of inertia about the point where we want to be actually to find out. Okay, and what is IC here? IC is the well-known moment of inertia we have already known. There are some of these shapes here, and the moment of inertia of that shapes, particularly standard shapes, is we are already known. So what are these shapes? The shapes are, first of all, the shapes are, I am going to give the shapes are here. There are different shapes. There are very standard shapes. The first shape is ring. Their first shape is ring. Second shape is disc. The third shape is cylinder, which is hollow cylinder. The fourth shape is solid cylinder. Okay, and now the fifth shape is hollow ring, and the seventh shape is solid ring. Sorry, ring, not ring. It is actually not ring. It is a hollow sphere, and solid sphere. These are the mainly standard shapes we are going to deal with. Okay, and we must have to be very well aware of that the fact that we should be known about the moment of inertia, all these standard shapes. We should be known about the moment of inertia of the ring, the moment of inertia of a disc, moment of inertia of hollow cylinder, moment of inertia of solid sphere, solid cylinder, hollow sphere, and solid sphere as well. Okay, so here so that is so what I'm actually going to say, that IC is the moment of inertia that we have already known through these formulas. There are different formulas of it. And what is M? Here M is nothing but the mass of given shape. Here, if it is a ring, for example, let's do, if it is a ring, the mass is the M is actually the mass of the ring. The M is nothing but the mass of the ring. Okay, M is the mass of the ring. And what is H? H is nothing but the perpendicular distance between two parallel axes. Let's see here. This is the first line which is perpendicular to the plane of the ring, and here the next axis is this, and these two axes are perpendicular this ring plane, and these are parallel to each other. If these are the parallel to each other, H is nothing but the distance between these two parallel lines, and this is the perpendicular distance between two parallel lines. So we have clear here, the M is the mass of the ring, H is the perpendicular distance between two parallel axes. And what is I naught? I naught is the moment of inertia where we actually to be find out the moment of inertia at point O. Okay, so this is the actually parallel axis theorem. Now let's look at here let's understand what do you mean by the perpendicular axis theorem. Perpendicular axis theorem is given by Iz is equal to Ix plus Iy square. So look at here in this figure, look at here this figure. Here we will clearly getting what is IC. IC is Ix is the moment of inertia in the direction X. What is Iy? Iy is the moment of inertia in axis Y. Iz is the moment of inertia in axis Z. And what are perpendicular axis theorem says? Perpendicular axis theorem says the moment of inertia at z is the moment of inertia at z is equal to ix plus iy. If we add the moment of inertia at x and moment of inertia at x and moment of inertia at y, we can easily find out if we know about ix and if we know about iy, we can easily find out iz by using the formula iz is equal to ix plus iy. So let's take up one question on this formulas. So first we look at upon the parallel axis theorem. What is the question here? There is a simple the first thing you should be known in this case, there is a shape given here is a disk. The shape given here is a disk. Just wait a minute. Here the shape given is a disk, and we wanted to find out the moment of inertia at this point O, which is on the circumference, and the axis is actually perpendicular to this disk. And we wanted to be find out the moment of inertia at O, means the axis is now at the O and we want to rotate the whole disk around this axis, and we must have to be find out the I naught. How can we find out the I naught? I naught is given by IC plus mh square. And where from we are getting this formula? We are getting this formula from the parallel axis theorem. Parallel axis theorem says that I naught is equal to IC plus mh square. But what we had meaning of, what we had learned about the IC is the fix for, actually we are known of very well known aware of it. What is IC is the moment of inertia. This here look at IC is this. IC is the moment of inertia at the center, the axis passing through the center, here this disc sees a center and axis passing through the center, and IC is very well aware of it, and we should have to be just rectify what are the ICs. Okay, for the disc I am directly giving the formula. ICs, the moment of inertia is mr square by 2. Okay, these are the rectification, mr square by 2. There is a derivation for it, but for the time sake IC is very known fix. And what is IC? The IC is a rotation, axis of rotation passing through the center, which is mr square by 2, and the next is ms square. Okay, m is the mass of this disk. Okay, and h is nothing but the perpendicular distance between two parallel axes. This is one parallel axis, this is second parallel axis, and h is the perpendicular distance between two parallel lines. So what is here h actually we are getting from it? H is nothing but r. So just put out the value of h as r and mr square. So what we are getting? 3 by 2 mr square. 3 by 2 mr square. So I got the moment of inertia at O point when I am well known of moment of inertia at C. Okay, that's it.